Hello, college algebra. I thought maybe I'd try to help you with a little chapter 5 stuff. In section 5.2, section 5.1 was inverse functions. Maybe you could, there's a video on that. There's been a video on all this, but I found these homework problems. I don't know. I thought I'd help you. In the homework, in section 5.2, there's this question: can you graph this function? So you know you got to use the graphing features of MyMathLab. But I taught you a little bit about this. I taught you that what we got here is either exponential growth or exponential decay. It depends on whether that base is bigger than 1. It depends on a couple things. But if that base is bigger than 1, it's good old growth. You could plot some points, but you know that base is bigger than 1. That's E. That's 2.7 something, something, something. So this is growth. You know, if you plug in a 0, you get E to the 0, which is 1. If you plug in a 0, that's usually the y-intercept, but wait a minute. You get e to the 0, which is 1, times 5/8. So I guess the y-intercept is 5/8. And then what did I say? It's exponential growth, so here it is. I mean, I don't really need to plot a lot of points. There is this asymptote here. The graph approaches this asymptote here, gets closer and closer without ever touching it. It's called y equals 0. It's this kind of imaginary line. You know, I draw it as a dashed line because it's not really part of the graph. There's the graph, but the graph is approaching that asymptote. So I just graphed that for you. You know, there's a Smith quiz out there. It's due in a few days. It's on Canvas, and it's got a little better version of this question. It's got something like this. Y equals 5e to the 3x minus 8. So it's, I don't know, yeah, put a 5 and an 8 in it. Anyway, I just made up a different one, but this is more like a Smith question. And, you know, one of the main things, and you learned this in previous chapters, when you put a minus 8 on the end of a function, what does that do when you put a minus 8 on the end of a function? It shifts the whole thing down. And so this is another example of growth, but it's the whole thing, and it's not really exactly this picture at all. It's a little different, but it's shifted down. And what that really means is that asymptote is shifted down. So, so hang on. What I asked for is I asked for a graph, and I asked for a lot of important information. I asked for what is the horizontal asymptote? What's it, you know, what is it? I asked for the domain. That's easy. I asked for the range. That's easy. I asked for the x-intercept and the y-intercept. This is a typical Smith question. This is a lot like one on your Smith quiz. It's due on Canvas. All right, well, anyway, we just talked about shifting it down 8, and so there is an asymptote that would normally be here, but it's shifted down 8, so guess where? It's at negative 8. There is a horizontal asymptote. So what's the name of it? Y equals 8. I'm sorry, negative 8. Y equals negative 8, that horizontal line. It's not a point, it's a line. Okay, well then the graph, you know, does something here. Let's see. The y-intercept's always so easy. You plug in a 0 for x and you get the y-intercept. And so you plug in a 0 for x, you get e to the 0. That's 1 times 5 is 5. Subtract 8, it's negative 3. Negative 3. You might have thought that the y-intercept is at number 5. Well, it was at number 5 until it got shifted down 8. So now it's down at negative 3. That's one way to think about it. Or, I mean, it was that number, but it got shifted down 8. Or you could just plug in a 0 and do the math. We got negative 3. Okay, now hang on. Here I go. I'm ready to draw it. You know, it's that famous exponential growth, or maybe it's exponential decay. This one again is growth. You know, with that base E, it's growth. Now, one way to make it decay is if I would have had a negative 3x. That little negative sign up there makes it decay. But this one's growth. I've got an asymptote. I've got a y-intercept. So there's a beautiful picture of it. That's all you need. Nice, accurate picture. Good. There is a few details we should fill in. Let's see. The y-intercept was negative 3. I can work on that x-intercept. Let's do this domain and range. The domain's real easy. This exponential function spreads out over all x's, so the domain is all real numbers, negative infinity to infinity. And the range, you know, is everything above this asymptote. And the idea that it doesn't cross this asymptote, it never touches this asymptote. So it's all y values greater than -8. Y values greater than -8, I guess. All right, good. The x-intercept. There is one. In the previous example, it never touched the x-axis. The answer would have been none. But because we shifted this down, there is an x-intercept right there. And of course, how do you find an x-intercept? You let y equals 0, and you solve for x. All right, so then now we're doing a little solving, which I taught you how to do. You add 8 to the other side. You get 5e to the 3x. You divide by 5. 8/5 equals e to the 3x. And now we're trying to get rid of the e, try to get the 3x down, and we use the inverse of e, and everybody knows that is a natural logarithm. So we take the natural logarithm of the 8/5, we take the natural log of the other side. Of course, all that does is the natural log cancels the e, and it leaves me 3x equals the natural log of 8/5. Let's divide by 3 and we have our answer. The natural log of 8/5 divided by 3. I'm just going to punch that in the count. I mean, I could write that as my answer. I want to see what it is. It looks like a little decimal of some sort. I need my calculator and my glasses, and I get the natural log button. There's another log button. I want the natural log button of 8 divided by 5. I get a little decimal, 0.47. Then I divide by 3. And I get a little 0.156666. We'll call that 0.157. And that's an approximation, you know, that's the exact answer. This is my approximate answer. Anyway, as long as I see your work, I like to see your work. I don't care what you write over here. As long as I see your work, there's the exact answer. Here's our estimated answer. All right, good job. Listen, let's do one more little problem here from 5-2. So this was my problem. You don't see this in the homework. This is the Smith kind of problem. Back to the homework. In the My Math Lab homework, I saw this problem. I'm going to get rid of this. I'm going to get rid of it in case you want to hit pause. I'm getting rid of this. There was one of these investment problems where you put some money in the bank, it earns interest, and the amount of money you have, it grows. And we learned about these formulas. I'll write them down again. There's this famous formula, P times 1 plus R over N raised to the NT. This is for compounding interest N times per year. We've also got this formula. I won't use this in this example, but this is classic. This is for compounding interest continuously, which is like every split second. And other things grow continuously. Populations grow continuously. Money grows continuously. Radioactive substances decay continuously. So this is a very famous formula. We use it up in 5-6 if you saw that video. But back in 5-2, they had me introduced to this. Compounding interest N times per year. And I've just found this problem in the homework. They gave me, this is problem number 8. In the homework, they gave me a P, $53,180. That's kind of weird. They gave me an interest rate, 3.5%. They gave me quarterly. They say you're compounding the interest quarterly, and they say you're going to do this for 4.5 years. The time is 4.5 years. So when you see this word quarterly, that's the number of times it's compounded in a year. The interest is given to this person, this account, and quarterly is every quarter of a year. How many times a year is that? I guess it's 4 times a year. So when you read that word, N is 4. That's what we need. We need N is 4. There's other problems where it says it's compounded monthly. If it's compounded monthly, N is 12. If it's compounded daily, how many days are in a year? N is 365. All right, this is not too bad. We're looking for the future amount of money. They gave me the original amount of money, and here we go. 53,180 multiplied by 1 plus the interest rate R. Now, hold on. You got to write that as a decimal. You know, it's funny they gave me 3.5. I would have given you 3.5, which is 3.5. But then you got to write it as a decimal, which means you got to go 0.035. Did I do that right? 2 places over. Yeah. Divided by n, which is 4, raised to the 4 times t. How many years did we have it? And that was also funny. 4.5 years, which I'll call 4.5 years. So my exponent is the 4 times a year for 4.5 years. I got to multiply those. I got to divide that. I got to add it to 1. I pick up my calculator and I do this in kind of in slow motion here. Here we go. What is that? 0.035 divided by 4. So I divided this and I get this little decimal 0.00875. Of course, then you add it to 1. So you get I'm going to add it to 1. Add it to 1. 1.00875. My advice is do not round that number. That number highly affects the answer. It's raised to the 4 times 4.5. 4 times 4.5. That's an 18. That's nice. And then this number's in front. Don't raise this. This is not raised to a power. This is waiting out front. This is the base. This is the exponent. And so now I'm ready to do a couple more moves. Let's see. I got the, the 1.00875 raised to the 18th power is some little decimal, 1.17 roughly. I'm going to go ahead and multiply by the 53,180. And the answer is 62,208.85 cents. In all these money problems, we should round to the hundredths place, which is the pennies or the cents. Cool. That was fun. All right, I got some more. I'm going to help you with some more homework in 5.3, maybe 5.4. You can send in some requests if you need requests. All right, keep working hard.